All right, so I'm getting the thumbs up that we are ready to go. And I'll probably need all the time that I have, so let's get started. So, good afternoon, everybody. I hope you had a great lunch. I'm really excited to be here and to talk to you today. For one thing, this is my first in-person conference that I've been to in a while, so it's great to be together with you in this nice room here. And secondly, I get to talk about a topic that I really like, classic adventure games. So that's really cool. So in this session, I will show you how we can build our own adventure game with Blazor and in .NET. So my name is Sander Molenkamp. I'm a principal cloud architect at InfoSport, which is a Dutch IT consultancy company. And I'm also a Microsoft Azure MVP. And I've been around for a while. I was born in 1978. So that was just a couple of years after the first real text adventure game was released, which was Colossal Cave Adventure. So in this game, you had to explore this mysterious cave where full of hidden treasures. And this being 1977-ish, it didn't have any graphics whatsoever, so this was a real text adventure game. So the game would describe a situation to you, and then you had to reply with these 1 or 2 word commands, and then you got ahead in the game, and it would describe the next situation. Now, the first game I actually remember playing was King's Quest. This was released in 1984, and at that time, adventure games incorporated real graphics. So you could control your on-screen character, like in Crane here, using the cursor keys on your keyboard. But then if you wanted him to do anything else but walk around, you still had to type in a command, like pick up an object. And that was a bit problematic for me, because at the time, when I was playing this at a friend's house, I was like 8, maybe 9 years old. And my English vocabulary wasn't that, well, it was pretty limited, to say the least. So it was pretty difficult for us to get ahead in the game. Well, that became less of a problem a couple of years later. So for one thing, we do have some English in our elementary schools in the Netherlands, so that certainly helped. But also these adventure games keep evolving further onto these real point-and-click adventure games. And the first real example of that is Maniac Mansion from Lucasfilm Games. So what you see here on the screen is in the lower part, you see all these verbs. And below that, you see an inventory of all the items that the players collected. Now, instead of having to type commands, you could simply point your mouse and click on a verb and click on an object in a game, and that would execute some player action. So that was much easier for me to play when I was younger. What's also interesting about Maniac Mansion is that they created this game engine for it called SCUM, or Script Creation Utility for Maniac Mansion. And that basically allowed the game designers to write these more abstract high-level scripts without having to worry about the actual underlying platform or the actual hard-coded programming language. It's really nice. As you can see here, it's almost like being a bit of a movie director where you can just tell your actors to do stuff. And it makes it simple to script such a game. Now, SCUM evolved, and it got used in a lot of the Lucasfilm games over the year. So the mid-80s basically represent the start of this golden era for adventure games, at least here in Europe and over in the US. And a lot of the real classics were released during this golden era, which lasted until like the mid-90s. And then it steadily declined, and a lot of first-person shooter games came up, like Doom and stuff. So this is a favorite of mine. It's called The Secret of Monkey Island. So what I want to do in this session, and what I wanted to do initially, was to try to create a game like Monkey Island, that feels like Monkey Island, that looks a bit like Monkey Island, with the same type of gameplay, but build it entirely with Blazor and .NET. So why Blazor? Well, because I can, and because I wanted to learn Blazor, so I thought this would be a nice sample application to try to create in Blazor. So Blazor it is. Now, I started thinking about how to do this, and in good adventure game tradition, I came up with 3 main tasks. So the first one is, how are we going to actually design this in Blazor? Blazor applications are entirely composed out of components. So at a high level, the question becomes, if I want a UI like Monkey Island, then what type of components do I need? How do I design these components? How will all those different components interact with each other? And of course, Blazor is used to create web applications. And as we all know, we use HTML and CSS to style web applications. But I want something to look like a real adventure game with some nice pixelated graphics and stuff. So just using HTML and a bit of CSS probably isn't enough. So second challenge is going to be how do we render some nicer graphics. And then I also really like that idea of having a separate script interpreter like Maniac Mansion does. So I want to build my own scripts, and I need to have a scripting engine for that can dynamically interpret that script and drive the UI. So that's going to be my first challenge. So we will walk through all of these one by one. Starting with Blazor. Now, you may not know it, but we're at a really special occasion for a Blazor talk. Because back in 2017, Steve Sanderson from Microsoft held a presentation, I think it was actually in this very same room, about all the cool things that web apps can do if they run client-side in a browser. And in one of his demos, he showed a .NET application with some Razor pages running client-side. And that was a really amazing demo. And it was also the first public appearance of what would later really become, or officially become, Blazor. So Blazor is this framework for building single-page applications with .NET. That means I can write my code in C# instead of JavaScript. This is great news for me because I'm a really lousy JavaScript developer, and I'm at least a bit of a decent C# developer. My coding experience is mostly from backends. So now I can reuse those skills to also build client-side applications, which is really nice. And that also means is that I can reuse all of those NuGet packages that I know and love, and almost all of them will just work with Blazor. There are some exceptions. So if you have a NuGet package which uses a certain network protocol which isn't allowed from a browser sandbox, that may not work. But overall, most of them just work as expected. And what's particularly nice, if my backend is also in .NET, it's now very easy to share code between my client and my server. And that's especially nice for things like message contracts or validation code, stuff like that. Now, there are two ways to actually host a Blazor application. Up to now, we've mostly talked about Blazor as something running inside a browser, and that's called Blazor WebAssembly. But you can also run Blazor on the server. So to start with Blazor WebAssembly is basically this instruction set. So what happens is that your .NET application gets translated into these WebAssembly binary formatted instructions, and then your browser can execute those instructions, and now your .NET application runs in the browser. So that's a really high-level overview of it. The other scenario is hosting Blazor on the server. So then your application actually runs on the server, and any input from the client is being sent to the server over the SignalR connection. So SignalR is this real-time messaging framework. Then your server process executes the logic, and any UI changes are sent back over that same SignalR connection back to the browser and merged into the DOM. Now, Blazor server does have some benefits. For example, you can pre-render your content, which makes it much more friendly for search engines that can then discover your pages. And it also runs on browsers that do not support WebAssembly. Although WebAssembly supports pretty good, I tried running it on my iPhone this morning, and that works as well. So for this game, I'm definitely going to use WebAssembly for two main reasons. This is a point-and-click adventure game, so that kind of implies that there will be a lot of mouse events going on, and it's just way more efficient to handle those directly in the browser than sending them up to some server component. And I also like having no server component, because that means that my application is basically just a bunch of static files, and it's really easy and cheap to host that. So WebAssembly it is. Okay, so let's take a look at the design of my Blazor application. So as I said, a Blazor application is composed out of components. So basically everything is a component. And you can think of a component as reusable bits, like a date picker or a text box. But also the top-level pages are components themselves. And I'm going to have two top-level pages in my application. I'm going to have a select game page, where the player can obviously select a game. And then when you select a game, you will be redirected to the play game page, and there you should be able to actually play the game that you selected. And that should obviously look a little bit like this, ideally. So for that, I'm simply going to identify a Blazor component that will make all of that happen, that will display this UI. And that same component will also be responsible for loading my GameScript, and we'll get to the GameScript at the third part of the session into the details. But for now, just assume there's a GameScript. So this GameView component takes that UI and that GameScript and makes sure that it works together. But this is obviously going to be quite a big component if it needs to do everything. So we can divide this up into some subcomponents. So for example, if you look at the lower left bottom, you have this area where the player can pick a verb. So we can extract that into its own component, call that a Verb Picker. And then similarly, over on the right bottom side, we have our inventory view, which is responsible for displaying the user's inventory. Above that, we have this action bar. And the action bar displays the current action that the user can execute. So, for example, if I were to click on, let's say, look at in the Verb Picker, then the action bar text should change to look at. And if I then hover my mouse cursor over the shovel in the inventory view, then the action bar should change to look at shovel. And if I then click on that shovel, then the action bar should detect, hey, I've got a complete command, look at shovel, and it somehow needs to trigger that GameScript to run the command. And then I've got one component left, which is the room view, which will need to take care of the rendering of the scene, of the world. And that look into the world is traditionally called a room in Lucasfilm games. It doesn't actually matter if the character is in an actual room or is outside in a forest or something like that. It's always called a room. Okay, so let's look at one of these components, see what that looks like in Blazor. So here's a sample of the Verb Picker. And as you can see, it's basically a combination of some HTML, some C#, and some Razor markup syntax. So what I do here, I first check if it needs to be visible, because at some points in the game I don't want to show the player controls. I only want to show what's happening in the world. If it is visible, I will render all those verbs. I'm only showing 3 here because otherwise it wouldn't fit on my slide. And then each verb is rendered in a span. I have a onClick handler on that span. So if the player clicks on that verb, that handler will go off. And at that point, we should probably let some of the other components know that the player has clicked on a verb so that they can react to that. So if I click on a verb, one of the components that needs to know about it is this action bar, right? Because the text must be displayed. But there are a lot of other interactions. For example, that action bar also reacts to the inventory view and the room view if you mouse over things or click on things. And then if you actually execute an action, such as look at shovel, then that GameScript must be triggered. If I click in the room, then the GameScript must also be triggered because the position of my character will change and the GameScript needs to know about that. When the GameScript runs the actual game logic, the UI needs to be updated to reflect those changes in the GameScript state. So there are also a lot of interaction going the other way. So all in all, there's a lot of interaction going on. So to fix that or to implement that in a nicely, loosely coupled way, I decided to use a really simple pub/sub pattern and implement that in a mediator object. So as an example, let's say that I click on pickup and then I click on a newspaper object in the world. Then the action bar will detect that, oh, you want to pick up the newspaper, I'm going to execute a player action for that. So it will create an execute player action command, and it will send that to the mediator. And then my GameView component is subscribed to that command. So it will receive the command from the mediator. The GameView component is also responsible for managing the GameScript. So my GameScript here is just an ordinary .NET object. It's not a Blazor component. So the GameView will call the GameScript, and then the GameScript will do whatever is scripted, and it will start sending these events to update the UI. So for example, it may send an item added to inventory newspaper. Send it using that mediator again, and then my inventory view is subscribed to that event, because once an item is added to the inventory, it must be displayed on the screen. So now it can do that. So keep in mind that there's no messaging infrastructure underneath this mediator. This is just an in memory pops up implementation. I think the whole mediator code is like 60 lines of code, something like that. All right, so let's look at some of the code, see how we use that mediator. So this is the source code for the play game page. And at the top, you can see it has this page directive. So this is basically the route for the page. And that includes a disk number. So this number is just my unique identification for a game. So I know what game you want to play. And then I inject the mediator into this instance. So the mediator is registered with the .NET Dependency Injection Framework, and then I get an instance here that I can use in my play game page. Now, if we look down a little bit in the HTML, you can see there's my game view component. And then if you would look into this game view component, you would see the other components like Verb Picker, inventory view, and so forth. But it's surrounded by this cascading value element. So why do I need that? The cascading value element basically makes that mediator instance available to all of the nested components within that cascading value element. So now my game view, but also the other deeper nested components can all have access to that mediator object. So let's see what that looks like in one of these components. So let's dive into the game view component. Here again at the top you see some stuff being injected. I won't go into it. I need it. I need those classes to load a game. Then I check if the game script has any errors. If it does, I render those on the screen because it will make my life much easier to debug it. But otherwise, if everything went well, I can render my UI, and my UI consists of these other 4 components. Now, if we scroll down a little bit in this file, we can also see the C# code. And there we can see a parameter for that mediator, and the parameter is decorated with the cascading parameter attribute. And because this is a cascading parameter, it will get that value from that cascading value that I defined in the page. So it will now have this mediator. And I didn't give the cascading value a particular name, so the matching here is based on the type, which is iMediator. Now, why do I need these cascading parameters here? Because I could have also injected the mediator into this component, right? Just like I did with the page component. And I could also inject it into these deeper nested components, like the Verb Picker. Well, have a look at this scenario. So let's say I'm playing a game number 1, and I decide I want to quit the game and I want to go play another game. So I go back to the selection screen. My play game page, including all of the nested components, will now be disposed because I'm on a different page. So now I'm going back to the play game page, but another instance, a new instance of the play game page to play game 2. So what happens with the mediator instance? Well, it kind of depends how I register it with the dependency injection framework, because it depends on the lifetime that I give it. And in Blazor WebAssembly, you can choose between singleton lifetime or transient lifetime. There's no concept of scopes in Blazor WebAssembly. So if I define or I register a dependency as scoped, I simply get the same behavior as singleton, which is always give me back the exact same instance of the mediator. And I don't want that, because if my page 2 gets the same instance that was used for page 1, that won't work, because that mediator has all kinds of registrations on it for components that don't exist anymore. So I definitely don't want that. So maybe I should register it as transient. Well, I don't want that either, because then every component will get its own version of the mediator, and they won't be able to talk to each other because everybody's talking to his own mediator, to which nobody is subscribed. So what I really want is, I actually want the lifetime of the mediator to be tied to the lifetime of my Blazor page. And I can do that, if we look quickly at the play game source code again, I can do that by registering my mediator as transient, so that each time I go to the play game page, I get a new instance. But then using that cascading value with cascading parameters to pass down that same exact instance to all of my nested components. And that will make sure that everybody is talking using the same mediator. Okay, back to my game view. So of course, now we have our mediator object, but now we need to subscribe to messages coming in from that mediator. And a good place to do that is this Uninitialized method. So this method is called once when your component is created, and it's called after the parameters have been set. So I can be sure that I have my mediator object. Now it registers a handler called onStartGame async, and if I scroll down even more, then you can see that here on the screen. So what I do in this handler, I first try to load my game manifest using the disk number. Now, the game manifest is just this simple YAML file that I created that contains the locations of the scripts and the images that my game uses. Because I need to know where they are, I need to load them in. So I try to load that manifest file, and then I publish it in this game manifest loaded event. And that's just to make sure that any other component in my game, which may also need the game manifest, can now subscribe to this command and or event and has access to it. So then I load the actual game script from the manifest, and if that's succeeded, I can run that script, and then the script will take over. It will start publishing events, and it will basically drive the UI from that point forward. So that's all nice and well. But we still need somebody to actually trigger that start game command, because this will only be set in motion if that start game is actually sent to the mediator. And that's done in the back in the play game page. So in the play game page, after rendering has happened, I trigger that first start game command. And this onAfterRender async method has this really nice parameter, first render, which you can use to check if it's the first time that the component is rendered. Because I only want to start the game once, of course. So I check that variable first before I send it. Now, I do need to make sure that when I send my first command, that all of the other components have already created their subscriptions on the mediator. Because if they didn't, I can send a command, but nobody is listening, or they may miss some messages. Now, if you remember, in the game view components, that subscription was done in the Uninitialized method. But there are actually two versions of the Uninitialized method in Blazor. There's this synchronous version, which you see here on the slide. There's also an asynchronous version called Uninitialized Async. And in this sample, I've added some long-running operations. Let's say we're loading in a lot of data from a database or something that will be really asynchronous and will take a while. So what has happened now is that now my Uninitialized Async method returns an incomplete task. And the thing to remember here is that Blazor will not wait for your incomplete task to complete before it starts rendering. And that's actually a good thing, because it allows you to render things like a progress bar or a spinner while you are doing a lot of asynchronous setup code in your Uninitialized. So it's a good thing, but we need to make sure that we subscribe to the mediator before calling any async code. And if we do that, then we can be sure that all that synchronous setup code is done before we reach this point in the code, which is the onAfterRender point. All right, so let's show you something that actually works. Let me take my time here. Okay, so this is my first demo. It's called Cheese Quest. A lot of these games were ending in the name Quest. So this is my select game page, right? So it's basically shows the title of my engine, which is Game-a-Tron 4000, and then it shows all the games that it has found and that I can play. So if I click on Demo 1 Cheese Quest, you can see at the in the URL, this is the play game page, and this is disk number 2. Now, it doesn't show much yet, but it does show, it does do some things right. So if I open my console, you can see that there are already flowing some events through that mediator. So for example, here we can see the game manifest was loaded, then the game was started, then the protagonist was changed. Now we don't see a protagonist on the screen yet because we don't have graphics, but behind the scenes a protagonist was selected, which is the character that you play with. And then a room was entered. Now again, the room is pretty dark and it's basically a black void, but the mediator stuff is working. And also communications between these Blazor components are working. So for example, if I click on the look at verb, you can see that a event verb selected has been published and that the action bar now displays the text look at. And if I go over these, you can all see that this all interacts together. And there's even a little bit of gameplay in this amazing game. You can use a cheese grater with a block of cheese, and then of course you get some grated cheese. So it's truly amazing what you can do with modern technology. Yeah. Now obviously this doesn't look a bit like Monkey Island yet. We've got this huge black void up on the screen, so we need to do some graphics. So let me press Q here, and that will take me back to the select game page, and I can go back to my slide deck. So this brings us neatly into trial number 2. How are we going to render those graphics? Well, I'm going to use a library for that because I obviously don't want to start from the beginning. So I'm going to use Phaser for that, which is this really great HTML5 gaming framework that I've also already used for a bunch of other stuff. It gives you things like sprites and animations and input events. It also has some more sophisticated stuff like particle engines and textures and all kinds of cool stuff. So, for example, if I load in a sprite sheet, it's a sprite sheet from our main character. He's called Guys Guthrie. If I give this sprite sheet to Phaser and I set up some options, then Phaser can animate it for me and I get this nice walking character. Now I can draw. And this is actually something that a buddy of mine, Edwin van Wijk, drawed. But we just took the original Monkey Island sprite sheets and we draw over them with some different colors. And then you get these nice original characters without having to have any creative skills at all. So that's very nice. Now, the bad news here is that Phaser is a JavaScript library. And I already mentioned to you that I don't like writing JavaScript. But fortunately, Blazor provides some very nice features to integrate our .NET code with JavaScript, and that way keep the bulk of my code on the .NET side. But first, let's have a quick look at some JavaScript code to see how you actually create a sprite in Phaser. It's pretty easy. It's basically this one-liner. So you call scene.add.sprite, you give the location for the sprite. Alien is the name of my sprite sheet, and then front is the name of the image in that sprite sheet, and that will give me this alien here, which is not a character from the game. Now, this will give me a sprite, but oftentimes I want to set up some additional options for that sprite. So for example, maybe I want to set the depth. So the depth is basically the Z index or the Z index. So higher numbers, sprites with a higher number depth will be drawn on top of sprites with a lower number depth. Maybe I want the sprite to be interactive. That means it can receive mouse events like pointer down, pointer over, pointer out. And pixel perfect here means don't send any mouse events for the transparent pixels. So that the alignment is perfect. And then if I have mouse events, then obviously it's going to be interesting if I can also handle those. So here I register an event handler for a pointer down event, and I simply log a message to the console. So this is a little Phaser JavaScript 101, how you set up this sprite. So how are we going to call this from our .NET code? Well, Blazor provides you with this Ijs Runtime Abstraction that we can use to do that. So how it works is from my .NET code, I can call invoke void async, give it the name of a JavaScript function that I want to invoke, give it a bunch of parameters that I want to invoke it with, and then Ijs Runtime will marshal that to JavaScript and it will invoke that function for me. Now, a couple of things to note here. That function name is relative to the global window scope, and all of the parameters that you pass must be JSON serializable, or otherwise this won't work. You can also get a return value from JavaScript. So there's also this invoke async of t overload, which you can use for returning values. And the same holds here. That return value must be serializable as well. Now, each of these invocations will incur a little bit of overhead because of that serialization. So as a general rule of thumb, it's a good thing to keep the number of interoperable invocations quite low. So the way I try to do that is by adding this facade to Blazor. Right? As we already saw, I need multiple calls to Blazor to set up a sprite. So let's add a facade layer, which I can call with just a single call. So my Blazor interop.js file contains functions like this, add sprite, with really a bunch of parameters, and then it will make multiple calls to Blazor to set up my sprite. So that is a JavaScript file that I had to write. Fortunately, it's pretty easy to write because it just calls some Blazor APIs. And it's not too bad. It's like 200, 250 lines of code. The rest of the code's all C#. So now for my .NET code, I can simply invoke this single function and I save a bunch of interop calls. And there's another optimization I can make here. Because, well, let's go back one. If you look between .NET and Ijs Runtime at the invoke void async call, that's an asynchronous call. And the main reason that's async is to allow for Blazor server scenarios. Because if your application is running on the server and you want to call JavaScript in the browser, you definitely need to call over the network. But if I run in Blazor WebAssembly and I'm running in the browser next to the JavaScript engine, I don't need that to be asynchronous. I can make that a synchronous call. So I can actually cast Ijs Runtime to Ijs in process runtime. And on Ijs in process runtime, I can invoke synchronous calls. And that saves a little bit of overhead. If you make a lot of calls, I think it's around 4 or 5 times faster than the async versions. All right, next demo. This is not going to be an exciting demo, I can tell you already. So here we are at the first room of the game. And now we have our protagonist, Gijs Runtime, on screen. So that's great. And we also have a newspaper here lying next to the bench. So this is not part of the background. This is a sprite. So what I've done here is basically just add some sprites to the screen, right? But it's not interactive yet. So I can still select a verb in this verb picker to look at something. But if I now hover over this newspaper, nothing happens. And why is that? Well, that's because we've created some code to call JavaScript from .NET, but we haven't done anything to call .NET from JavaScript. So all the mouse events that Blazor fires, nobody's listening to them yet. So that's going to be the next part. Let's handle those mouse events and see if we can actually, because I cannot even move around in this demo, see if we can make this better. So let's go back and let's go back to my slides. Okay, so what I want is I want to be able to write handlers like this. So when my pointer is down, so when I click on a game object, I want to be able to invoke some piece of .NET code that can then handle that event. Now, to make any .NET method invocable from JavaScript, it needs at least 2 things. It needs to be a public method, and it needs to have this JS invocable attribute. And then you can call it from JavaScript. And you can see in this sample, I have this point position, which is the mouse position. That obviously also has to be serializable for it to work. Now, I've got a lot of these events I want to handle, and I don't particularly like having these public decorated methods at various places in my code. So what I did was I added an additional helper class called my Blazor callback class. And what this does is it takes a ordinary .NET delegate, an action in this case, and it makes that delegate invocable from JavaScript by adding this public method, decorating it with a JS invocable. So now if my JavaScript code calls this Blazor callback, then this callback class will call my action, and the action can be whatever I want it to be on the .NET side. And I also have 2 other variations of this class. One for the case where JavaScript needs to pass an argument, and another one where I want to pass an argument but also want to get a return value back. So let's say I have an action which a callback for some code that needs to happen when my pointer is down. I wrap that action in a phasor callback object to make it invocable from JavaScript. But now my JavaScript code needs to have a reference to this callback, because otherwise how will it invoke it? And I can get a reference by calling .NET Object Reference create. So .NET Object Reference is a Blazor class which gives me a reference object which I can pass over to the JavaScript side. And I can do that, for example, in the addSprite function. So when I add a sprite for a first time, I call that JavaScript function to do that, and one of the parameters will be this onPointerDownRef. So if you go over to the JavaScript side, here's my addSprite function in my phasor interop file that will get that onPointerDownRef. It will create the sprite, set it up. Then it will register an event handler for the pointer down event, and in that event handler, it can call invoke method on that onPointerDown reference, which will invoke my phasor callback, which will invoke my action, which contains the actual .NET code that I want to execute. So now we should be able to have some interaction. So for example, I can walk around in this room, and I don't know if you can see it clearly. It's a bit subtle in this room, but if I walk to the back of the room, I also scale the character a little bit just to get a sense of depth in here. And I can do things like look at this other sprite here, this top crate. So if I click here, guy will walk to it and will say something about it. Now you can see that the character is drawn behind the crate, which is correct. In this case. So I do a little bit of depth sorting based on the bottom Y coordinate of the sprite. So if that value is higher, then I draw it on top of sprites with lower value. And it looks all right if I show it to you now, but if I do things like this, then it kind of looks a little bit funky. I don't know what's happening here. So Guy now has a higher Y index than the top crate, so it will be drawn on top. And actually, let me try. Yeah, I can also walk on the ceiling of this thing. So still not quite there yet with the graphics. Okay, so let's fix that. Let me go back to my slides. Okay, what's going on here? So we can fix this by defining the area where the character is actually allowed to walk, and we can call that a walk box. So this is the walk box for the room that you just saw, and you can see this cutout at the bottom. That's where those crates are. So I don't want him to be inside the crates. So let's say that I click on any of these 3 points. How am I going to move to those points? Well, it's trivial because those points have direct line of sight from the position where the character is currently at. So we can just start playing the animation, move the sprite to that new location, and we'll be done. But what if the player clicks outside of the walk box, let's say at the red dot? Well, again, it's not that difficult to solve. We can just snap it to the nearest position on the walk box, and then again, there's direct line of sight, so we can just move the character there, and that feels pretty natural when you play the game. But what if I click in the lower left position? Because now there's no line of sight anymore. And the problem, obviously, is are these 2 vertices here. So these are concave vertices in this walkbox polygon. And that basically means they are inward turns. And they make it impossible for all the possible points to be able to see each other directly. So I need to route around them. And the way I'm doing that is I take those vertices, all the concave vertices in the polygon, I add the position of the player, and I add the position of the mouse cursor, because that's the point where we want to go to. And I then connect all of the points that are in direct line of sight of each other. So I get this nice graph. And then it's pretty easy to solve, because I can use a well-known shortest path algorithm over this graph to find the route to the location. And I didn't even need to implement those myself, because I'm writing .NET code, and I know of this NuGet package that I've used sometimes called QuickGraph, which includes a number of those algorithms like A star and Dijkstra. And being Dutch, I obviously use Dijkstra. So if I move this mouse cursor and I break that line of sight from the actor, I can still run that algorithm and find the shortest path. And that also works even if I go all the way down there. But let me prove it to you that it actually works. Let me see. This was revisited. OK, so let me first go all the way down here. And then go to that lower left position, and you see Guy walking around those boxes. I also cannot go all the way down here anymore, and I also cannot go to the roofs. So that works pretty nice. And I've built in this debug mode where you can see the actual walk box. And if I move the mouse cursor around, you can see what happens because it will change that graph. And the green line indicates that the line that I'm going to take. So if I go all the way down here to the left, you can see that it finds that path. Now, this is a pretty simple room. Let's go explore this UFO a little bit further. Let's go around this podcast booth here. Now, what's that doing in a UFO? So this is a quite more elaborate walk box. You can see there's also this alien bit in the way. But you can see that we can walk around him quite well. Let's try to... Oh, don't want to talk to you yet. You can also see the scaling effect better in this room. So yeah, walk boxes are fun and they work great. All right. Let's see, how am I doing on time? 18 minutes, okay. So now we have graphics. Now we just need that scripting engine and some game scripts to actually drive the game and implement some of the game logic, right? Now almost everything is C#, and I want to keep it that way. So I'm going to use C# script for the scripting engine. And that will look a little bit like this. So to add a room, I can call this addRoom method, and I give it an identifier for the room. And then I have this like Fluent builder-like pattern, which you can use to set up some additional settings for that room. So in this case, I call the with walkbox area to specify the walkbox area for the room. Now, in the same way, I can add actors to the game. So here I'm adding the main actor, Guy, and I make him untouchable because I don't want you to be able to click on the main character because you are the main character. And then I also add a newspaper. In this case, I give them a bit of a more descriptive name. So that's the name you'll see when you mouse over it. So the basic difference here, by the way, between an item and an actor is that an actor can also walk and talk, whereas an item is just basically a non-livable thing. And then I can add some code that I want to run when the game first starts. And I can register that code in my onGameStart method. So in this callback, I place both Guy and a newspaper in my park room. And then I tell the game engine that Guy is my main protagonist. So now the game engine knows who you are controlling. And then I tell the game engine to change the room to the park. And the engine actually checks if you've set a protagonist and you've set a room, because otherwise it wouldn't know what to do. It will just throw an exception. So let's look at that newspaper. Let me explain you something else. Because if you look at those methods, addRoom, addActor, onGameStart, those look like static methods, right? Because they aren't called on a class. Well, actually, they are called on a class. There's this hidden global game object. And that's the object that implements or declares all these methods. So what happens is when this game script runs, the game object gets called, and it will build up this in-memory model of the game containing all those callbacks like the onGameStart callback. So I only need to run this game script once when I'm loading the game. Once I've run it, I've got the in-memory model, and that's used for the duration of the game. So now let's look at the newspaper script. Because you can also use the script to script behavior. So let's say when I want to look at the newspaper, I can use that same Fluent interface to define what must happen when you look at this particular object. And in this case, I first check to see if Guy has picked up the newspaper. I can do that by calling the has method on an actor. And if he did, I say it's yesterday's paper. If he didn't, I let him say something about newspaper lying on the ground. And I can do the same for other verbs. So for example, when you call pickup on this item, I add it to the inventory of Guy. So again, it's really more like a movie script. You've got these nice high-level instructions. You don't need to worry about how this is actually implemented in the code. You can just be concerned with your game logic. And what actually happens under the hood, if you call any of these functions, like say line, is that it generates events. So if I call say line, it generates a line spoken event. Those events are then published using Mediator. And of course, our Blazor UI components are subscribed to those events, and they can render the graphics that are needed to display the reaction. All right, so how are we going to compile that script into something that runs in my Blazor application? Well, I'm going to use Roslyn for that. And part of Roslyn is this Microsoft Code Analysis C# package, which has a very nice C# script that evaluates async static methods, which you can use to execute some C# code. So really easy. The only downside is it doesn't work in Blazor WebAssembly. If you run this, you get a not support exception, can create a metadata reference to an assembly without a location. Okay, so what's happening here? Well, Roslyn will try to get metadata references for some of the core assemblies, for example, the assemblies that implement the object type, because you need those references in order to be able to execute C# and C# script. So it will query the assembly.location property for that. And normally, assembly.location will return the location of your assembly file where it is on disk. But in WebAssembly, there isn't a file system, there isn't a disk. So assembly.location will simply return an empty string. And Roslyn doesn't know what to do with it, so it just throws this not support exception. Okay, so to fix this, we will need to go a level deeper and use some of the lower level Roslyn classes to make this happen. And it's a bit of code, but works kind of great once you have it. So first, let's try to load those metadata references. So what I'm going to do is I'm going to basically iterate over all of the assemblies that are currently loaded in my application, and I will create metadata references for them all. So my script will have access to the exact same assemblies. That's probably a bit too much for what the script needs to do, but it's easy to write this way. So I iterate over those assemblies, and I then need to load the assembly. Now, all those assemblies are stored in this underscore framework folder in my Blazor application. But again, no file system, so I need to get at those using an HTTP client. So I make an HTTP client GET request, then I get a response back. I can read that response as a stream, and from that stream I can create a metadata reference. And then I have my list of metadata references that I can give to Roslyn. Okay, so next step, actually compile my script. So the first thing I need to do is I need to use C# syntax tree to create a syntax tree for my source code. I then set a couple of compilation options. So for example, I want to create a dynamically linked library and also set some implicit usings. And this is nice because that means that the author of the game script doesn't need to include explicit usings for some of these often used namespaces. Then I create a new script compilation that needs to have a name. I just create a GUID for that. I need to specify the type of my globals object, which is that game object that I talked about. So I specify that, and then I just specify the options, the references, and the syntax tree, and I'm good to go. So then I can call cat Diagnostics, and that will return any errors that may have happened during compilation. So if there aren't any, let's assume there aren't any, I'm ready to run the C# script. And for that, I need to have an assembly. So what I can do, I can call compilation.emit to emit the IL code, the generated IL code, into a stream. And then I can use that stream to load an in-memory assembly. And then I need to have an entry point. And I need to know which method do I need to call on that assembly to actually run the script. And with C# script, the assembly contains a script class with this really weird-looking factory method, including brackets. And that's my entry point. So that's the method I need to call, and then the script will run. So I create a delegate for that to make it easier to invoke. And as you can see here, the delegate has a parameter, or I should say the factor method takes a parameter of type object array. And that's a very special object array. The first entry in that array must be my globals object. So that's an instance of my game object. And then what Roslyn does, so each time I invoke the entry point, it kind of makes a state machine. And it stores that state machine in this submission array. So I must make sure that the submission array is large enough for the number of times I call the entry point. In this case, I'm only going to call the entry point once, so it's good enough to have an array length of 2 here. And then I can just do it, and the script will run. My object model will be created, and everything will be fine. So now I have my in-memory object model of the game, the rooms, the actors, and the items, and the game can run. But wouldn't it also be nice if we allow the player to also maybe create save games and load games? Because if you only have save games, that's not that useful. So how can we do that? So what I do is, as soon as the game starts, I create a snapshot of that object model. So I have a snapshot of the state of the model. And here's a JSON representation of that, of a really small part. So here we have an item called a fridge. The fridge is at a certain position. The status is closed, so the door is closed. Then I also have Guy, our main actor. He's also at a certain position. He's facing the camera, which means status is front. And then I have this UFO, and it contains both Guy and the fridge. Now let's say that I'm playing the game, and I'm moving Guy over to the fridge, and I open the fridge. And then I want to save the game, because I want to save often, because some of these adventure games were really brutal, and you had to save basically after every action you did. So now I take a second snapshot of my object model, and some things will have changed. So now the fridge is open. And now Guy is at a different position, and he's facing away from the camera. He's probably facing the fridge at this position. But also, a lot of other things have stayed the same, right? The UFO still contains Guy in the fridge still at the same position. So I only need to save that diff. So I diff those 2 snapshots, and this is going to be my save game. And what I do when I load a game, I start from that initial state, and then I add in this diff. And then I have the point in the game where the player left off. So now obviously when I want to save a game, when I close my browser, come back the next day, open on my browser, I would prefer it if my save game was still there, right? So where are we going to store this save game? There are a couple of options. I could introduce at this point a server component and put it in, I don't know, maybe Azure Blob Storage, or create a .NET backend that saves it in the SQL database, something like that. But I really don't want to introduce a server component in my application. I could put it in application storage, which would probably work fine. There's a limit in the browser application storage of like 5 megabytes, but these save games aren't really that big. But let's say they are big, and let's say there are a lot of save games, then maybe 5 megabytes is enough. Well, there's another option called IndexedDB, which is this NoSQL data store built into basically all modern browsers. And with IndexedDB, you don't really have a space limitation. It's more a limitation of the browser itself, how much hard disk it wants to use of your entire hard disk. And there's a JavaScript API for IndexedDB that I can use. So I can use a bit more of that JavaScript interoperability to call IndexedDB. But fortunately, I don't have to in this case, because there's this very nice tj.blaze.indexedb NuGet package, which already does the hard work for me. Now, it is a pre-release package, and it hasn't been updated in about a year. So I feel like that's not an ideal combination of things, but it works for my situation, so that I'm using it. So let's have a quick look at the final game and see if this truly works. So I'm going to load this up, and I'm going to again open my DevTools, and I'll go to Application. And here in Application, you can see all kinds of interesting stuff. And here you've got the IndexedDB. So if I open up IndexedDB, you can see that I've got a Game-a-Tron database. And in that Game-a-Tron database, I have a save game table. And let me make this a little bit bigger. In this save game table, I have a single save game already stored. And here is that state. Now, the one thing I don't like about this is that you see a lot of nil values. So everywhere you see a nil value, that basically means it hasn't changed from the initial state. And ideally, I would serialize it in a way that wouldn't include all those nil fields, but I haven't come around to do that with IndexedDB. So basically, this is my save game, so let me close it up. Now, I also haven't come around to create an actual UI for this, so I can use some global hotkeys. I can press S to save a game and L to load a game. So trust me when I say I'm now pressing the L button, and that takes me to a scene further in the game where I'm in this UFO, and you can also see I have this new newspaper which wasn't in my inventory before. So this works pretty good, and just to show you it really works, let's walk to a different location. I'm going to press S to save the game. Then I'm going to move to another location again. And I'm going to press L. And I should teleport back to that location where I previously saved the game. So that works very well, I think. Now, this opens up an interesting scenario because I'm debugging this game script quite often, and sometimes I want to make some changes. I do a bit of hot reloading, basically, of my game script. And I can do that by just creating a snapshot, loading the game script, and restoring that snapshot again. So let's see if that actually works. Let's walk all the way over to this podcast booth. So right now, if I look at the podcast booth, guy turns around, says, hey, it's podcast booth. Okay, so maybe I want to change that behavior. So let me go over to Visual Studio. So here's my solution. Here's the Blazor UI. I also have a core and an infrastructure project. If I drill down in the Blazor UI, you can see that in my root folder, I have this games folder, which are numbered by disk number. And disk 1 is my game. I can go to the scripts folder, and here's all my C# script for the items in the game. So if I now look for item podcast booth, here is the current script for the podcast booth. So it's an item named podcast booth. It has a certain actor interaction. So this is to set up the reaction of the protagonist to the object. So this is why guy changes its back to us when he starts interacting with the booth. And then here's that line, it's a podcast booth. So let's say I want to do something else. Let's say I want to turn him around. So I want, let's say, or he's already turned around, right? So I want him to turn back to the camera, face the camera. And then I want him to say something like, hey, they must have, oh man, I can't talk in live session. Must have beamed it up from NDC Oslo. Okay, let me fix this double space for my OCD. Let's save this. Go back here, and now I'll press R for reload. Refreshing game script, or R for refresh, I guess that works as well. And now I can say, look at podcast booth. It's a podcast booth. So this is a real lifesaver when you are creating scripts, I should say. All right. So with that, our trials are done, and I think we've succeeded quite well in creating our own adventure game. I've got a couple of links for you. So this is all open source. You can get the source code. I just updated it this morning. I was actually still working on the demos last night and this morning, so I'm still tweaking quite a bit. If you look at the source code, there are really a lot of to-dos still in there. But hey, it's there for you to, for your pleasure. You can also play the game at this URL here. If you do, and if you succeed in finishing it, it's really a pretty short game. Please let me know. You can reach me on Twitter. I would love to hear from you. If you think, okay, I'm interested in Blazor, but what else, all this adventure game stuff? I also have a more typical Blazor example in the eShop on Dapper repository, which is basically an eShop where you can buy some t-shirts and stuff. So you can see how a Blazor application would work in a more realistic scenario. Last thing I want to plug, I also have a YouTube channel together with my buddy Edwin van Wijk. It's called On Netflix. We talk about all kinds of Microsoft stuff. So that might be interesting to you as well. With that, thank you so much for joining me, and have a great rest of the conference. And if you have any questions, I'll stick around here, or otherwise outside the room for a while.